Great. So welcome. I think we'll get started. My name is Andy Ballester. I am the Chief Product Officer of EyePop.ai. Our mission is to make computer vision more accessible. This is a technology that is amazing for a wide variety of use cases, but it can often be hard to access, especially for software engineers coming to AI and coming to machine learning for the first time. And so what you'll find today is, as we talk through some of these examples, is about taking the concepts of computer vision and bringing them to a web API level to make it much easier to access. Everything we're going to be doing today is going to be using the EyePop cloud, but you'll see, and please sign up to get our newsletters, but we will be rolling out edge deployments this year. And in fact, should have some more announcements this month about edge deployments. And so would love to circle back, and we'll be doing some workshops around edge deployments as well. With that, the first thing I'm going to do is I'm going to share my screen around, and we're going to look at the EyePop dashboard. The EyePop dashboard is where you create a lot of the initial endpoints that we're going to be using today. And so let me share my entire screen. Okay. I will set up Zoom to get it out of the way. Perfect. Okay. This is the EyePop dashboard, and on the EyePop dashboard, we have a list of endpoints here. We call these POPs, but they are API endpoints that allow me to do. They house both a computer vision recipe, which is a collaboration between models to give me real-world results, along with a worker server that works in the cloud to process my results. And so the first thing we're going to do today is just create a new POP. For the purposes of this workshop, we want to integrate the POP into what we are actually building today. And so we're going to use an API POP. I'm going to call this a text endpoint. Now, what that's going to do is I'm on a developer account in this one. And so it's actually pulling one of our AI worker servers out of our cloud pool in production mode. On EyePop, you'll actually have dedicated capacity, so that is an unnecessary step. You just always have a capacity that's dedicated to you, and that spins up really quickly. And even though we call this text endpoint, I'm actually going to show you a different pipeline first. And so in my account, you can see we have many curated pipelines of models we put together. And the first category is all about people. And that's one of the first things I want to show is how do we find people in the scene? How do we measure them? How are they posed within the scene? Where are their body landmarks? We have a person and common objects. This is a catch-all pipeline that we put together often for just looking at common everyday objects, finding those in the scene. We have some expert detection models that are a little bit more specific. And the one we're specifically going to be focused on today is our text detection. Okay, so first I'm going to set this to person with 2D body points. We are going to hit continue. That's going to deploy that combination of models out to the cloud. I now have an endpoint that I can use. We have starter code down here. We're going to be looking at the Node SDK through React today. And so we can see this is some example code that we can use. We put the example code that we're going to be using today into GitHub, and so you can find that in the links in chat. We're also going to be looking at the Python example. This we're going to be looking at pretty directly. It's almost exactly this for the initial implementation that we're going to be starting off in Python, and then we're going to be adding some like bells and whistles to that. We also are plugged into Zapier and Bubble, and so if you want to use our implementations through those platforms, you can as well. So some important things to look at on our POP. The first thing is the UUID. We're going to be using POP UUIDs pretty heavily. We can click this to copy our UUID. We also need an API key, and so if you don't have one already, this will be a button to generate an API key. You can click that. It'll allow you to copy once, save that API key, and then from then on, you won't have access to it. You can always reset and roll a new one if you need to, but that's for security. Okay, before we get into coding, I want to show how the platform works. And so we're going to be looking at the preview experience. This is our sandbox. This allows us to interact with our POP in a way that requires no coding to first just initially see if our POP is doing the things that we want it to do. The first mode I'm going to interact with my POP in is image. And so I'm going to just choose an image. And remember, we're on the person with 2D body points pipeline. And so what this does is I chose an image of myself. This uploaded, we have this nice visualization. That's fun. But what I really care about is what's on the right here. And that's the JSON result that comes out of this. And so we've just turned with our POP in a few minutes here from an image to JSON, which is highly integratable in whatever programming that I'm doing. So my app or website can use this data then to take a look at things like, is there a person in the scene? If there is, we have that object described in this nice bounding box. Where are they in the scene? How much of the scene do they take up? Are there multiple people in the scenes? By looking at these objects, we can tell how many people we found. We can look at points of how I'm posed in this particular scene. Where is my wrist in relation to my elbow, or my wrist in relation to my shoulder? Am I raising my hand? Do I have my hands below there? Where am I looking? How is my head positioned? That is all described in these key points here. We also have, we brought the code over to this screen as well. And so if you're interested in what you're doing on this side, you can cut and paste that code really easily. The second mode we'll be looking at right now to interact with my pop is in live web stream mode. And this is useful for taking data from my webcam, and it's just spinning up right now. That'll pop in. Excellent. And so this is taking data from a webcam. It could take it from any live source. You can also pipe in, for example, just like Zoom has screen sharing, you can actually pipe in a screen into this and identify objects or conditions on that screen. You can take in other live sources from other live webcams as well. And so what this is doing, we saw very similar to the image of me. It's also identifying me with a box. And so as I change my visual real estate in the scene, that box is changing with me. It's in real time identifying parts of my body with body landmarks. And so I can tell, my wrist point versus shoulder points, things like that. This works across full body. And so we have ankle points, hips points, those things as well for use cases like sports analytics, and discovering, how are people positioned in relation to each other, in relation to a product or a space, all of that kind of stuff. What we did not have in the image example is this ID. And this ID is a unique identifier to me within this scene around a person. And so in this frame to frame, we're able to identify the person that we saw in the last frame is the same person that is in the next frame. And I can tell that by this ID not changing. This ID will follow me around the scene. If there were another person in here, that would also give them a different unique identifier for this particular scene. Now, this is not using techniques like face identification or anything like that. This is using geometry. It's using other re-identification techniques. If I leave the scene for a length of time, it's going to forget who I am. And as I come back, that'll be a new person. It will work through small times of inclusion or occlusion, or if I leave the scene for a second, come back, it'll keep me there. So what we're going to do today is I wanted to show the person pipeline. I think that's a really fun starter example. We're going to be talking about text today. And so the goal of this workshop is to build some scripts around extracting text from images and live video. You can also extract text from saved video, those MP4s, or your users' videos from their phones. We're not going to look at that today, but you can use the same code we're using today to extract text from videos as well. The first thing I'm going to do is we could create a new endpoint. I don't particularly need this extra endpoint, so I'm just going to change it on the fly. And what this allows us to do is change the pipeline that my pop is pointed to. If I've previously integrated with this UUID, I don't have to change any of the integration points here. I can manage that right from here. When my pop is in production mode, there are additional checks around that, so you don't change a production mode pop on the fly. That might have implications to your to the code out there running. One of the nice things about this ability is one of the things we won't talk about today, but we will have some other workshops on, is the ability to create pipelines around any object or condition you're looking for. And that's using our self-service training. And so I've created a number of models here. I have an example, eyeglasses. My eyeglass model, as you often do in AI, have to take a lot of different versions of that to refine that use case. And so I've added more data here over time between these different models. I can then deploy that model out to the cloud. That gives me some model statistics on how well my model is doing. I can also deploy my model. And so this is a model that finds eyeglasses in a scene. I can deploy it with our person in 2D body points. I can also deploy it with text. So if I want to find a product and then read the text off of it, I don't have to do extra coding here. I can just deploy them together like Legos. And so right now we can deploy out to the cloud. Very soon you'll be able to deploy out to different edge surfaces as well. Okay, and all right, so we're gonna pop through here. So one of the things that I find very handy around the ability to change my endpoints on the fly is I'm able to upgrade my endpoint or the model that my endpoint is pointed to on the fly here without recoding or changing IDs out or reconfiguring what I'm doing. And so we can see that here. I have a list of my models as well that I could go and, I could change from version 5 to version 7. We're going to be using text today. Let's throw one quick example of text through the preview experience. And so let's see. One of the things we're going to be looking at today is extracting text from driver's licenses. I have an example license here from a movie. And so we can see we found quite a lot of text on this driver's license. And we can see here all the results that we got back in JSON. And so through this workshop, one of the things we're going to look at is, okay, how do I make sense of this information and this result I'm getting back? All right. So right now, I am going to switch to, now we're going to be building this into our Python example. And so here we can take a look at some of the pieces of code that we're going to be looking at in Python. Number one, you'll need to pip install the EyePop SDK to make this a lot easier. And then here's an example of cut and paste code that I can take and put into my Python code. I'm going to bring up my screen here. And so in this first version, we're doing almost exactly that, that minimalistic, hey, we want to upload an image. And after we've uploaded that image, please process that image and give us our results back. So what I'm doing here, number one, I'm importing our EyePop SDK. I'm also importing the JSON package that allows me to pretty print the JSON that's going to come back here into the terminal. And then I'm going to load my environment variables. In this case, the two environment variables that I care about are my EyePop pop ID and my secret key. And so I put that into my environment Python here. There are a lot of ways we could hand an image over to the EyePop SDK. You can specify a file path. And in this case, we have two files we're going to be looking at. We're going to be looking at this garden sign. Can we get the text off of this? We're also going to be looking at this handwritten chalk message for the Python example. These are just two real world examples of things I may want to pull text off of. So in this example, we're going to be uploading directly these local files to my AI worker server. We also could specify a URL that's publicly accessible. We could send a blob. We could send a video. We could send anchor point to a live stream. We'll be looking at live stream today in the React mode, but you can do this in Python as well. Okay, so I think the biggest thing here is that we initialize our worker endpoint correctly. And so here, pretty easy. You can also, in our documentation, we talk about how you can put these into your OS environment variables, so you don't even have to manage your secret key and pop ID in code. We often find for production environments, that's a much easier configuration for folks. I'm doing this explicitly here to just show how this would work in the case where I just want to pipe some code at this thing with minimal configuration. So first we initialize our endpoint here. Once we have that endpoint, we're going to upload our example image, and then we're going to call predict. That predict will actually do the inference. It'll extract the text and send that back to our result variable. And then we're just going to simply print the result to the terminal. And so I've prepared this code. Let me clean up this terminal here. And let's run our number one, which is just uploading and getting a result back. And so we can see it uploaded that first example image, and it gave us back our result here. We can see it found one piece of text, and that's welcome. So that looks good, but I would really like to kind of verify this in a bigger way of like, did it find the text in the right spot? If I'm trying to measure that text in some way, how big it is, where it is in the scene, I may need a little bit more visualization to help me out here. So let's extend this like very bare bones code into a visualization step. And that's going to be in our number 2 Python here with visualize. Just like before, importing the SDK and some of our support libraries here. I'm also going to be using a library called Pillow to open this image up and so that we can see it. And we're going to be using matplotlib as a way to draw to that image. And so that's going to help us render what we find. Just like we did in the sandbox environment on the dashboard, we can do that in our SDK code as well. And so in this one, just for fun, let's switch images this time around. So we use the text example number 1 there, and we can go back and forth and we can do both. I'm going to initialize my worker endpoint here. I have tightened up this code now that we've kind of taken a look at this already. I'm going to do the same thing again. I'm going to upload the image, and then I'm going to call predict with our SDK. That's going to then print out that result. We're going to do a new step here. And so With the text pipelines, we found that this generally doesn't matter as much, but there are use cases in which you want to filter the text by confidence. And this is a concept that I find a lot of developers who are new to computer vision, machine learning, and AI, they have a lot of questions around confidence. And so what confidence is how sure is this pipeline or this particular model at what it's finding in a scene. And so it's going to give you a score back. And we can see that score here. Each object has a score. And in the text pipeline, the text itself also has a score for confidence. And so how confident that the bounding box that the model is describing is text, that's this first confidence. And then the second is how confident is it that it read the correct text from that area. And so in this particular use case, these are both very high confidence scores. We have seen in some real world use cases, especially if you're trying to live stream find a particular piece of text in the field, there may be times you want to filter for only the highest confidence text that you're finding in the scene. And we're going to be looking at some live stream examples a little bit further in this workshop. And so we'll see some examples of that. In this case, I can enter anything between 0 and 1 here as a confidence threshold. Right now, I'm keeping it at the absolute minimum. We're not going to filter out anything, but I wanted to call this out in case you wanted to use this concept of filtering by confidence. When in future workshops, we're going to be using very similar code because you can see there's not a lot of code that would change if I'm finding text versus finding a person in a scene. And so for that more object detection, around like real world objects, there's a lot more confidence thresholding that I'll want to do as part of my development process to figure out what confidence works for my particular use case for this set of models. Okay, so what this does is it looks for anything, filters my result set by confidence. Once we have these filtered objects and that filtered result, we're going to then go and show that image. We're going to then use the EyePop SDK's plot to connect to the image, and then this plot prediction to send in our filtered result that will actually display a bounding box around what it found. And so let's do that now. Bring up my terminal here. Let's now do number 2 and visualize that result. And so this went out to my AI worker server in the cloud, uploaded this image, came back with a result, and we drew over top of this image this text box. And so we can see right here, this text is referring to the label of the box, and the object that it found in the scene was text. Now we want to get to the place where we're actually reading the text out of here. What did it find? And so we know where the text is in the scene right now. So in the next example, let's put all the things we've been talking about together. And let's actually look through the filtered results. Let's look through all the objects coming back. In this case, you can do something with, you could actually loop through every object and look for interesting things here. In this particular case, we're just going to display the first piece of text that we find out to the actual image. And so not a lot of crazy code here. We could get really complicated with how we're finding text. We could actually check that text against our own databases. In the case where we're looking for products, we could store that text as just an ongoing log of what we found in a live stream, all kinds of things we could do here. So let's take a look at how that works. And so now it's going to go out with the same image, get the result back, visualize it, and we're also going to visualize what text we found. And so this is just this is the text we found. So great, looks good. We found that text in the real world scene. Let's also go back to our first image. So I'm just going to change the example paths here. I'm going to rerun that same code. And great, we're also finding the word welcome in this one as well. Perfect. Okay, I'm going to now switch over to our React shell. And what we did to help showcase a more complicated implementation of the EyePop SDK is we built this React shell. What this React shell is a way to access, number one, the user's camera, allow you to use their feed to put through an EyePop pipeline live. Just like we were doing in the previous step, this allows us to do that live inference, and every frame I could be looking for a certain object or condition. The second thing it allows us to do is if the user wants to click and take a picture of a particular object, you can click and take a picture, and that gets sent to your pipeline for processing. And then on the result, there's a step of post-processing and looking for the actual object, or in this case, text that may drive product workflows or other things within our product. And then lastly, it allows us to upload images or video into our pipeline. So really a multifaceted kind of sandbox for you to hang your own product experiences off of. And so let's take a look at what that might look like. And so this is an example. I'm just going to refresh here. And so in this case, we can see the live running shell. It has this live preview. This is what my camera is seeing in this specific case. I haven't turned on any inference yet. It allows us to take a picture and upload a photo. Okay, so let's actually make this shell do something with EyePop. And so the first thing I would like to do is we just looked at uploading to EyePop static images. Let's go and look at actually processing something live. And so what I've done is I've separated the EyePop specific code into these processors so that it just makes it a little bit easier to segment, what is the UI element of this particular example versus what do I need to actually code to process the result from my AI worker server. And so the first one we're going to do is actually this text live. I'm going to switch the processor we're looking at over to text live. I'm going to save that. What this is going to do is number one, we're going to initialize the camera. After we initialize the camera on the page, we're going to pass in that video stream. We're going to pass in the canvas context, and that's what we're looking at right now. We're looking at a big canvas in the web mode. We're going to pass in the video stream, and that will allow us to, one, pass this video stream to our AI worker server. So it's going to look a little bit different than our image upload here. Very much like in Python, we're going to initialize our worker endpoint. In React, it looks slightly different. We pass it very similar information. I have these, my pop UUID and API key, same ones we used in Python in my environment. And so we're pulling that out of my environment and passing it into the worker. We're going to connect to the worker endpoint. And now we're ready to do work. Once that connection happens, we're ready to start doing work with our AI worker server. I'm also going to initialize a renderer. This renderer library is our library to help you visualize what's happening on the scene. We can render things like contours, which are outlines of objects for specific pipelines. We're not going to look at that today. We are going to look at rendering the text, and we're also going to look at rendering boxes around objects that we find in the scene. So this renderer is just a library to help that visualization. We have documentation around writing your own custom visualization. It's pretty easy. You're working with just pretty straightforward coordinate system here. So pretty easy stuff. We're also going to pass in our stream into our endpoint. And so the way we do that, instead of using endpoint.upload to upload a file, we're going to use endpoint.liveingress to actually initialize our stream. And what that does is form, in this case, a web RTC connection, same technology that we use all the time for video chat. It's going to initialize that to my AI worker server. That allows the AI worker server to tap into this stream as long as it's open. And then we're going to process those results coming back using the live ingress ID we get back from our endpoint. And so this is a unique ID that, if I connect in and somebody else connects in, these are all different streams coming into my endpoint that are being processed. Okay, when we get results from our endpoint, they are going to be placed into the property last prediction. And so there's a lot of things that I could do in this scenario. I could save all of the predictions that come back from each frame into a big buffer for processing if I'm interested in that. I could be doing quite a bit of different things here. We're going to throw away every result except for the last one in this particular use case, because all we care about is basically what is on screen right now. So there's a lot of, we wanted to keep it simple for this example. So this is how I initialize a live stream in React. And that's what gets what's happening right now. It's trying to read my shirt. We can read things like the Coke I have here in real time. And so one of the things about our text pipeline, it does not have to be flat surfaces. It does not have to be printed. I can use things like my terrible handwriting to find things, and we'll be going back to the handwriting example. I can find text on products. And so these are the couple examples we're going to look at live stream today. So let's imagine that I want to find that book that I just showed. And so when I find that book in a live stream, I may want to do something. This is useful for lots of different product experiences where you want to know that we could be running this same code on my consumer's phone just through the web. And so we could offer a web experience where they're pointing their camera at particular products, and we're doing something when we find them. And so if we look at how this works, on the page, every time we render a frame and we're writing that frame to the canvas to allow the visualization of that frame, we can actually call, let's see here, let's go, try on canvas, perfect. Okay, so every frame, what we're gonna call is something called process frame. So it allows, this draw is just pure visualization of that video stream. So no EyePop things going on here, that's purely just web and UI. Process frame allows us to actually do something interesting. And so what we're looking for there are two different scenarios. We wanna find when you see the Boba Fett book that I just showed. We also want to find when we see thanks on anything. And so what we've done here is every frame, the first thing we're going to do is we're going to use the renderer class to draw the last prediction that we've seen back from the server. And because of the low latency of WebRTC, that's going to look pretty good. It's going to be very close to frames. On videos that are batch videos that I upload, this code looks slightly different because I have a better capability to match the exact frame of that video with the exact prediction from that frame. But in this one, we're just going to deal with the tiny amount of lag from moving this back and forth. We're going to then look in the last prediction. And remember, these predictions, these are results coming back from the system. They're all going to look, very similar to what we saw in the Python example. And so I've written a helper function here called look for word, and that's just going to loop through the last prediction that came back and look for a particular word. And in this case, we're going to look for boba. If we find it, we're going to put a small, just a small note at the top left of the screen that we found the Boba Fett book. If it finds the word thank you, same thing, we're going to put you're welcome. And so let's try that out. And so in this case, it's finding text on me. It's not, it's processing, it's rendering it, but we haven't found that thing we're looking for yet. And so it's finding the word boba. We can see it's visualizing at the top left of the screen that it found that word within our result set. And so we have that visualization there. And then in the handwritten example, so I just wrote the word thanks. We can find it's looping through all the words that it's finding, including what's on my t-shirt. And it found thanks. It says you're welcome. So that's the first example. We could do this to make some really rich live user experiences. And especially once we launch our edge deploy, this is a rich user experience looking for things in a camera stream that actually could all run directly on the user's device. And so if you are coding along, this is something that you can run by going over to the page TSX. After downloading this from GitHub, you can npm install, change this to the live mode, which is this processor number 1, and you can play with what is happening in the text live process frame. If there are other pieces of text you're looking for here, you can extend this code to build a prototype around that. Okay, all right, moving forward. The next example we want to show is when I add images to Meta, one of the things that Meta looks for is how much of a particular ad does text take up. And so I'm going to give an example. This is obviously a fake ad that I made yesterday, and a lot of visual real estate dedicated to text in this particular instance. We want to know of the visual real estate here, how much area does this text take up? And is it over the threshold of 20% that Meta allows? And so what we're going to do here is we're going to switch over to the text ad processor that we've built here. This is going to look a lot more like the example that we did in Python. And so if I switch over to the text ad processor, we can see very similarly, I'm initializing in this set canvas context. That's an initialization of our endpoint and renderer. We want to connect to our EyePop.ai worker server. We also are eventually going to want to render the result we get back out to the scene. But you'll notice in this case, I'm not instantiating the stream. I don't need to give EyePop access to the actual stream. We're just going to be using images in this use case. And so very similar to the Python example, in this case, the equivalent on the React side to the EyePop endpoint.upload is endpoint.process. I can give it a file. I could also give it things like a URL or a blob, and that will process that file URL or blob image. I can also pass in video in here as well. Okay, so what this will do is we'll process this the image that we upload to it through our AI worker server. It's going to give us our results back. I'm doing a little bit of UI code here. We can actually change the canvas. It just makes it a little bit prettier. Then we can use our renderer to draw the result back out to the screen. That's going to put our nice blue boxes over top of the things that we find. I then wrote a helper function to loop through all of the text objects and calculate their area. It takes that area and it then um, looks at the source area, which is our whole image, and just does it does a quick division here and makes it a percentage. And so nothing mystifying here. We're just doing height times width. Nothing fancy there. When I get that coverage percentage back, I'm then taking a look. Is it over the 20%? That is the threshold for meta ads. If so, we're going to say it's too high. If it's under 20%, we're going to say it's okay. All right, and let me double check that we did this. Yes, excellent. Okay, so I'm actually going to visualize this a little bit different. I'm going to refresh because I changed that scene. I'm going to now use my file uploader to upload our initial image that we know the text is very big on. And so here we go. Here is that ad. We uploaded it, ran the coverage percentage, and we can see it's too high. And you can kind of visually see as a human, that makes sense. It takes up a lot of visual real estate there. And so this could be a check that we do before we upload to Meta. It's also a check we could do for our own images within our system, or you could do other checks. You don't have to be checking the area here. You could be checking what is the word saying. Is this word within our brand guidelines? Is this word something that we want to put out there? Or do we want to just catalog all the words that we find in our library of images? Lots of different things that we could do with this sort of technology. Okay, so I can send this back to our designer and say, hey, we need to really shrink down that text. Let's see how we're doing on that. They redesign it, they come back, and then we have now a new image with lesser text. We can see, okay, 14%. This will make it through, Meta's criteria there. Great. All right. And the last use case that I want to take a look at today is around IDs. And in particular, in this one, I want to showcase that same driver's license that we had looked at before. We're going to be taking a look at that. We're also just going to be uploading an image in this case. And so I'm going to switch the processor over to the text license processor. In this, just like before, initialize the endpoint, initialize the renderer, and in process photo, send in the file that we care about to be processed. When I get the results back, do something. And instead of looking for the area in this case, we're actually going to be looking for specific words and the relation of those words to each other. And so to showcase this without to see this without any visualization on top of that, we can see there's a label here on this particular license number. And we know what comes after that number is the actual license number. And so imagine if we had a million of these things and we want to extract just the ID number out of this particular thing, we could extract other data too. I'm going to showcase how we would do just that ID number first, and then and you can extend the code to get the rest of the information out of this. But I want to read whatever that is, and we're going to visualize it on top of the image. But I could also use that to pull into my database. I could check it against a database of known IDs, all kinds of different things we could do once we have that number in a variable. And so what we're doing here is first I'm looking for that label of number. That's going to allow us to get an anchor point of where we can find the actual ID number in the scene, because they're all different. We need to know where to look. We also could do this just by geometry. We know on a specific state and version of an ID that it's always in the same spot. So we could do this geometrically too, of just like, I know that I should be looking in a general area for that number. So give me the text that you find in that particular area. So lots of ways we could do this. I find this is a little bit more extendable to lots of different things. Instead of having our geometric kind of rubric for each ID, we could just look for labels and then find the corresponding value for that label. So in this one, we're looking for the word number. We're finding the text to the right of that number on the same general height, and then we're going to print that out onto the ID. And so this code looks a little daunting. It's just UI code to visualize that on top of the ID. All right, so let's bring up our form here. I'm going to refresh it to bring up the new processor, and we're going to upload our ID in here just using the upload. And so we can see it found the text number, it found the actual ID, and then we have that number visualized here. And so if I had a plurality of these IDs, I could run them all very quickly through my AI endpoint worker server to convert these images into usable text that then I can use in my product or database of services. All right. Well, thank you everyone for joining today. It was super fun. And we're going to be doing a lot more of these. If you'd like to learn about some of the other ways to use EyePop, our next workshop that's virtual will be all around people and how to use person detection to do dynamic zooming in a video, to do highlight reels, all kinds of different ways we can use people. And so please join us for the next one. We'll also be recording all of these and putting them back out onto to different social media. And so you can even just sign up and get the recording later. That's fine too. But it was good seeing you all and talk to you soon.